All right. Now I think we're ready. Good morning. It's morning here. Uh,
It's
and
yeah, it's 6 p.m. in Astana, so
all right. Well, wonderful.
evening.
Hey, we're hanging out. I'm Deshaun, and this is Kat. Kat, for those that don't know you, would you mind introducing yourself?
Yeah, so my name is Catherine Edelveis, or you can call me Kat. I'm a developer advocate at Bellsoft. And in my free time, I'm a Java developer and Spring Boot developer. But mostly I work for Bellsoft and doing some content for them, writing articles, recording videos, and what's not.
Well, that's great. That sounds familiar. The writing and trying to like get the
Yeah,
stuff out so people understand the cheat codes. I like to call these things cheat codes.
yeah.
So today we were going to talk about like how do we make our Java workloads start up faster. Does that sound like a
Mm-hmm.
plan?
Yep.
How long have you been doing this?
Right. So I've been, I want to say messing around with, but experimenting with the Java startup time reduction since I joined Bellsoft because we have, basically we have already had the solutions for reducing the Java startups, such as a library native image kit, which is a GraalVM community edition based native image compiler. So it's already there. And then it just went on, and there is app.cds and support for app.cds in Spring Boot. And then there is the coordinator storage checkpoint project. And then the early access builds of Project Layden. And there's so much. And you just want to try it all out and see what you can do. And so my goal right now is to write tutorials, write record videos on using all these solutions so that you can try them out with your project and will maybe choose the best solution for your project and for your needs, because they all have, I wouldn't say that challenges, but some of them are a little bit trickier to implement than the others.
All right, should we jump in?
Yeah.
All right, I will. I'll bring your screen up here.
All right. Okay. So I'm going to use our favorite Spring Pet Clinic.
Oh, I've heard of that.
Usually Spring Pet Cleaning starts in about 3-4 seconds on my machine, and I'm using Apple M1 Mac, which is quite old, maybe 3 years old.
I happen to have a copy of it here. I'm gonna go and see how fast it starts up for me because I don't really know.
All right.
But yeah, you can hit that button. There's a little. It says StreamYard is sharing your screen, and you can hit that hide
Yeah.
button.
Hi. Yeah. Oh,
Yeah,
sorry. Yeah.
yeah. There you go. All right, so let's do it. Let's see where
Mhm.
we're at.
Yeah, so we are using Spring Pet Cleaning, right? And first, we are going to build a regular container with a regular jar file. And here it is. So there is nothing fancy, absolutely. No CDS, no AOT, no exploded jars, nothing. Just plain old, good old jar file. And it's as simple as that. So we are using Liberica runtime container with a Liberica JDK21 and Alpaca muscle. And we are simply packaging our application, and then we're transferring the jar file into a fresh base image with the JRE already, because we don't need the JDK to run it. And we just simply run it. As simple as that, right? So let's see what we can do. Let me share my screen.
Java Dash Jar. Good old Java Dash Jar.
Yeah.
This'll work.
All right. So, um, so I'm going to jump into the directory with the Docker file, and so we are building.
Nothing up our
The
sleeves. We're
yeah,
doing everything from scratch. This is good.
everything from scratch. So you can see I've been experimenting already with building the images. So
I mean, this is.
uh, so we are
Oh,
building right now the standard app.
Siva. Hello. How are you? Uh, Thanks for joining. It's so good to see you. And congratulations on your new role. I know you'll do great things.
All right, and our image is ready. So let's check it, and it is 200 megabytes. Well, right now we are not exactly paying attention to
Image size.
we can, yeah. So
Yeah.
I'm going to discuss later if we have time. And so the most exciting part, let's run it. So run. That's not the one I wanted.
We don't need that yet.
Yeah, just don't look there. That's a very advanced stuff that we are going to cover later on. Right, STD. Right, okay. So I'm just going to do it as that. So take a run, and we're going to remove the content because we don't need it, and we are going to expose the port. All right, so very traditional. Oops, sorry. And our containers by cleaning CDS. Oh, sorry, STD. Yeah, I'm a little bit nervous. Oops.
Siva says there's no way he was missing this talk.
Oh, that's so cute. Thank you, Siva.
Siva, I'm gonna want to get you on here soon. So.
Right. So application is starting, and as you can see, it started in almost 5 seconds. Right.
Okay. So that's just a normal startup. We didn't do anything fancy.
Yeah.
This is our baseline. Start it one more time, and that'll be our baseline. We'll get some hey, it's not just the once. We'll get some numbers going, and that'll be the baseline that we're working from.
Yep. All right. So starting again.
5 seconds.
Almost the same.
4 seconds, 5 seconds. Yeah.
Yeah. Almost like that. Okay. So let's see what we can do about that. Right.
All right. So there's a question already from the audience. Hey, we came in a minute late. Are we going to go over the crack specification, coordinated restore checkpoint? I don't know if we're going to go over the spec, but I think we're going to show a demo of it, right?
Yeah, we're going to show the demo. I'm going to explain just in a couple of words how it works and how it functions, right? So because crack actually needs the whole separate webinar for itself. I mean, it's very complicated.
But stay tuned, right? You're going to see it. It works. It's fun. It's a very cool.
Yeah, it's going to be there. Yeah, so
stick around. And we don't know how long it's going to take. We don't have real time limit. It will be done when it's done. If you've got questions, what I like to say is, when you come to my house for dinner, if you leave hungry, that's your fault. So if you're here, you're joining us. We're talking about making Java start up faster. If you have questions, you don't ask them, that's your fault. Don't leave hungry.
All right. Any questions? I will be happy to answer. All right. So let's move on to CDS. And how we can implement
CDS.
that.
What does CDS stand for?
Right. So CDS is a class data sharing. Actually, we can call it app CDS, application class data sharing, because right now it can load not only JDK system classes, but also the application classes. So when you start the application and then stop it, it creates an archive of pre-initialized classes. And then when you start your application in production, the JVM reads the data from the archive. And reading the data about the initialized classes is easier, right? And faster than initializing them from scratch. So this is how the startup gets faster. Right?
Fantastic.
So we already did some job.
I like this.
And,
good morning, Dan.
Yeah.
And hello, Anbu. Welcome. Thanks for joining.
Right. And we are going to use not only AppCDS, no, because Spring Boot enables us to use AOT processing. So ahead of time. Yeah. And we can couple it, with the CDS. Right. And usually it's used for GraalVM native image, but it's also a very good friend of CDS. And the only thing you have to do here, again, for CDS, it's really simple. You don't have to change anything in your application. Nothing in your configuration. So you only need to add this goal to your Spring Boot Maven plugin or Gradle plugin if you're using Gradle.
Okay.
Process AOT, and that's it. Right? So, and let's look at the Docker file. And the good thing is that you can actually containerize your app with CDS using build packs. So there's no need to write a Docker file. And the only reason why I'm showing the Docker file here is just I just want to show the process.
For clarity. That makes absolute sense. Because we like to say that friends don't let friends use Docker files.
Docker files, exactly.
When you have build packs, why would you want to do all this work? Because then you have to maintain it.
Yeah. So, and using CDS with the build packs is pretty simple, actually. So.
I'm going to say one thing, though. you're using Liberica runtime container, and
Mm-hmm.
it says JDK 21 stream muscle.
Muscle, yeah. Liberica runtime container, it is a container based on Liberica JDK and Alpaquita muscle. Well, in this case, muscle, but glibc version is also available. So Alpaquita is a very lightweight Linux distribution. It's Alpine, 100% Alpine compatible. So it's just as small as Alpine. But as it has two versions with muscle and glibc, it's more flexible, because if you've been using the glibc version, glibc based Linux, then it would be easier for you to migrate to another Linux distro. And thanks to the fact that Alpaquita is so small, we can build smaller container images, which is also important, right? So
Yeah. The other thing that's on my mind is I know, excuse me, when we're building native images, I know that there's a difference between using muscle and not. And the muscle has a little bit better compatibility. The native image has a little bit better compatibility and a smaller image. Uh,
yeah.
so
Mhm.
So this is something that maybe I want to dig in. I know I have an open issue from one of our other friends of the show around being able to do native images with muscle inside of a build pack. So we'll circle back to that, but that caught my eye. First thing that we saw that caught my eye. So we'll circle back to that. But this is
Yeah.
exciting stuff already.
Yeah, it is. It is. And yeah, I'm going to talk a little bit more about native image when we come to that. But yeah.
Okay.
All right. So the first stage is, just the same. We are packaging our application into the jar file. And then on the second stage, we transfer the jar file into the fresh base image. And so we are extracting layers. So we are creating a layer jar with the jar mode tools option. Which the layer jar is it looks like that actually. So it creates several layers out of your application with by default it's dependencies, Spring Boot loader, snapshot dependencies, and application. And then when you transfer these layers into the new image, you can when you update your application after that, you can update one or maybe two layers, and the others are going to be pulled from the cache. So layered images enable us to accelerate the updates.
Okay.
This way. So and it's a CDS friendly layout. So that's nothing complicated here. All right, so we have extracted layers, and then we are taking the Liberica runtime container with the CDS support. So again, it's Liberica JDK, Alpaquita muscle, and CDS. Already preloaded CDS archive for the JVM. So we have here our layers, and then what we are going to do inside the container, we are going to, inside the image, we are going to first enable the AOT pre-processing. Then we're going to specify archive classes at exit and the name of the CDS archive. And this will create the CDS archive upon application exit. Then the next option is Spring context exit on refresh. So it means that the application will exit automatically. We don't have to do anything, right?
Okay.
After all non-lazy bins are initialized, which is pretty convenient. And the last thing is that we're using the jar launcher that knows how to work with layered images. And then that all happens inside the image, so while you're building it, right? And then when you run your Docker image with the same command as usual, simply docker run, this is what's going to happen. Again, we are enabling AOT, because we did that, right? And here we are already pointing to the created archive, and we are telling Java to use the archive and load the classes from there, right? And then again, there's the jar launcher that works with layered images. As simple as that. So all the heavy lifting, yeah.
This first run is the training run.
Yeah,
right? Where
exactly.
it's building the archive. Okay, that makes sense. This makes absolute sense. So that's where it's getting all the information that's going to share between the different runs.
Yeah,
That
exactly.
CDS archive. Okay, let's take it for a spin.
Yep. Let's see. Okay. Let me clear the screen. All right. So we move to the folder where my project is with the AOT enabled. And yeah, so what we're doing is we're building the Docker image. We're going to call it cleaning CDS, right? And we're using the Docker file CDS. Okay, that's it. As simple as that. Let's check it. So here it is, our image. It already takes 280 megabytes. Well, because it contains the archive, and we're using the JDK. And the most exciting part is to run it, right? Okay, CDS. So everything's fine, everything's fine. Okay. Whew, let's see. Okay, so as you can see,
Yes.
only 3 seconds. Yeah. Okay.
All right, we're cruising.
Do you want to run it again, just to make sure?
Yeah.
Okay. Right. So as you can see, the startup is faster. Well, about 40%, maybe a little bit. So
it's faster. We can do the math if we want to. We'll leave that up to the users. But congratulations. I'm happy to see that you're using Spring Boot 3.3.4. That made me smile.
Of course. Why wouldn't I?
I mean, it's been out for days. Of course.
Yeah. All right. So this is thanks to AOT processing. So we shifted some work that the JVM does to the training run, and we created the archive with the classes. And that's how we managed to reduce the startup. And again, there's nothing that you should change in your application. There are no incompatibilities, right? So the only thing that you have to remember about is to use the same JDK that you used when you created the archive. So you create the archive and run the application with the same JDK. That's important.
That makes sense. That makes sense to me. All right.
Well, that's already pretty impressive, right? But
that is like, there's no way that we can squeeze even more speed out of this thing.
Oh, well, let's see.
It's Java. Java's slow, right?
Yeah, but we can give it a little nudge.
Okay.
Yeah. So the next thing I wanted to show you is it's very exciting. So it's Project Laden. The early access builds are already available, and here they are.
Put that URL.
So it's on java.net Laden.
Yeah, I will put that into the chat.
Yep. And you can get the builds for x64 and for Arch64, right?
Fantastic.
Yeah. So they are not meant for production, of course. Early access means that you can experiment with them, see what they can do. Yeah, but
if your tests pass, why not take it to production, right?
Yeah. We're just testing. We're just experimenting. We're just playing around.
I'm looking to see if it's available in SDK Man, and I don't think that it is.
I'm not sure. I'm not quite sure that it's available there.
But I know how to install it from that local so that it shows up in my SDK Man as a local install. But we can do that later. Fantastic. All right, so I can go get it. Of course, I'm going to download it while you're doing yours.
Yeah.
And I'm downloading because I like to live on the edge. This is we're getting into stuff that I don't have a demo for. I haven't tried it out, so I'm highly focused and paying attention to this right now.
Yeah. So
Did we make any changes to our POM file?
No, there are no changes. So I can close it. We don't with Laden. We don't have to do absolutely anything with the application, well, yet, at least at this stage. And what Laden does is that it uses the power of CDS, right? So it also creates the archive of classes, but not only that, it also leverages some AOT optimizations. So in this archive, it stores not only the class metadata, but also profiling data and some compiled code. Right, so it already shifts more of the work that the JVM does from the production run to the training run. Yeah. So and as many AOT optimizations that we do, the faster the startup, right? So the less the JVM has to do in the production.
So that's the in my head, Project Layden is kind of a knob. It gives us a knob that we can use to fine tune our application startup time. We can adjust how much of the code we want to optimize at build time. Is that right?
Mm-hmm. Well, yes, actually, yes. Right now, there are several options available. So there is one flag that we're going to use that enables all optimizations, right? Which are
Okay.
there. So the generation of reflection data, dynamic proxies, code compilation, and so
These
on,
are the
right?
knobs.
So
So
all of
we're
that.
going to turn it all the way up to 11 for this demo.
Yeah, yeah. We are just going to start from
Fantastic.
well, from the top. Yeah.
Fantastic.
Yeah. Okay, so I have already downloaded the build, of course, and I pointed Java home to it. And so let's check the Java
Okay.
version. Yeah, so it's Layden pre-main. That's it. That's what we want. All right, so what are we going to do? Well, first we are going to create again the jar file with our favorite Maven clean package. That's just the start. All right, and here we go. So it's there in the target. The next step is to create the exploded jar. So exploded jar is a special layout which is recommended by Spring to be used in production because it enables faster run of the application. It creates the lib subdirectory with the library classes and the jar file with the manifest that points to this lib subdirectory. Right.
Yes.
And it's, well, you can use it even if you don't use CDS or Layden or anything, you can use this exploded jar and it's already
Yeah.
going to do good.
And one of the things that I noticed is even when I'm just using the exploded jar, just that jar tools, jar mode tools, I think it is.
Yeah.
Even when I'm doing that, my depending on when I take my calculations, my memory footprint is also smaller at startup. So it's
Yeah.
not eating as much memory, so I can have a smaller container. So there's a question here: is Project Layden similar to GraalVM?
In a way, it's the definite goal, the end goal of the project is to create fully static images, right? Just like the native image does right now, right? And the thing is with the native image that it might, because of these fully static images and because of precompiled executable under the closed world assumption, it's a little bit more complicated to use it, maybe with certain projects, right? And
Okay.
Layden right now enables us to perform some AOT optimizations, not all of them, right? Not like the native image right now does. But it is going to be, compatible with the broader range of projects.
Got it.
Right.
All right, that makes sense. So like I said, so I'm sticking with the metaphor where Project Layden gives me kind of an adjustable list or an adjustable set of options that I can choose how much I want to
Exactly.
optimize.
Exactly. Yeah. Yeah.
All right, fantastic. That makes
Right.
sense to me. But
Yeah.
right now we're turning it all the way up to 11.
Yes, so we are going to use all the optimizations that
Okay.
Layden has to offer, right? So, but first, let's extract the exploded jar, and here it is. So you can see the new folder, and here it is, the lib folder with the libraries and our jar file. And now, what we are going to do is we are going to finally run Layden. Here, what you have to note is this flag is a cache data store, Spring Pet Clinic CDS. Well,
Okay.
you can give it any name, but that's just going to be the name for our archive. And this flag enables all optimizations of Layden and the creation of the archive, right?
Okay.
Then we're using the context exit on refresh. It's not obligatory, right? So you can start your application, run it through different execution paths, and then stop it manually.
Okay.
But I've been running Pet Clinic with this option that exits the application automatically, and try to do it manually when and I didn't notice any changes in the startup time. So maybe it's going to be more visible later, right? So we
Okay.
don't know. But anyway, we're
So
going
right
to
now we're just going to do create the archive.
yeah. So right now
Okay.
we're creating the archive. So it's going to be the training run. The application is going to start. Everything is going to be initialized, and then the application stops, and the archive is going to be created.
Okay.
And we are pointing to our Explode HR. Okay, let's do that. So you can see the application is starting, right? So the usual stuff, and then I see this stack trace. Don't be afraid.
Yep,
That's
we get that on the training run for regular CDS as well.
Yeah. So it's perfectly okay. If
Yep.
you want to experiment with data, you can run it yourself and see what's there, what's there. But right now,
I've seen it enough where I'm not afraid of that.
Yeah.
So now we have a CDS archive that is optimized by all the things that are in Project Layden right now.
Yeah, let's see. So here it is. It was created. Right now, Layden creates two files.
Okay.
One with the archive with classes, and the other with the code, precompiled code. But in future releases, it's planned to merge these two files in one into the archive. But right now, again, there's nothing you should do. You just point the application to the CDS archive, and this second file is just going to be picked up automatically.
Okay.
All right. So, and the next part, the most exciting one, right? So let's run our application. The command is exactly the same, only that we are deleting these on refresh option. Okay. So nothing changes here. That's the same. So we are pointing to the archive, but when we run an application, the JVM will see that the archive is already there, right? So it will not try to create it. Instead, it will read it, right? Okay, and we are again pointing to our Explode jar. Okay, here we go. Right. And that's it. The application started in 1 second.
That's amazing.
Yeah, that's really cool. That's really cool.
All right. So we started off at 4-point-something seconds. Yeah. We got down to 2-point-something seconds. Now we're under 2 seconds. We're at 1.1. Just a little bit over 1 second. Yeah. This is pretty amazing.
A little bit. Yeah, it's amazing. It's really amazing. We are going faster and faster, right?
Yep.
Yep. Right. And the beauty of Layden is that, again, just like with CDS, you don't have to change anything in your application. Nothing. Right? Just take it and use it. And that's amazing. I like it.
What's cool to me is that you're using this with Spring Boot 3.3.4.
Yeah.
So there's a lot of, it doesn't seem, it started up, right? We don't know if there's any other issues, but it started up. Like, this is kind of exciting. I know that there's been a lot of work put into Spring, heading in this direction. I know that Sebastian Deleuze's last blog article, he talked about, hey, app CDS and looking forward to Project Layden. So this is exciting. That we're on the right path. I love the fact. And Project Layden is scheduled. Do we know kind of a target?
As far as I know, correct me if I'm wrong, I think the stable builds are going to be released with the JDK 24, but I'm not quite sure.
Yeah, my friend Billy, I think that it's supposed to be in 24. But I don't see that. Maybe I'll ask Billy, or if anybody in the chat knows. But yeah, this is exciting stuff.
All right, yeah. So I'm really looking forward to Layden, to stable builds. So the work is ongoing, and there are going to be, I guess, even more optimization, and maybe the application is going to start even faster, right? So right now, it's already pretty exciting, already pretty amazing.
Yes.
All right. The next step is native image. Right, so Spring Boot 3 supports native image from out of the box. It means that you don't have to configure anything. You just have to add the GraalVM Tools native main plugin, right? In Spring Pet Clinic, it's already there. If it's not in your project, then you simply add it. And that's it, right? Well, the issue with the native image is that it creates the fully compiled native executable at build time, right? And The problem is that it's not the best friends with the dynamic features of Java.
Right.
So
You
yeah.
lose. You have this trade off where, hey, I'm going to do a lot of these things at build time, which makes it so. Yeah, my dynamic class loading, I don't get that. Uh,
Mhm.
that makes sense.
Yeah.
It's a trade off.
Yes, but actually, it's not it's not mission impossible, right? So you can run your application with the tracing agent,
Hmm.
right? And you can run it through as many execution paths as possible, so that the agent could observe the running application and gather the data about the usage of the dynamic features. Then it creates the JSON file. Right now, it's one file with JDK24. The Graal VM for JDK24 creates one file for all metadata about the dynamic features metadata. But previously, there were separate files for reflection, for resources, for dynamic proxies.
Okay.
I'll just mention one. Right.
Okay.
And then you feed
Fantastic.
this file, then you feed this file to your native image compiler, and then it understands that these are the things that shouldn't be thrown out of the image,
Fantastic.
right? Okay. Right. So I just wanted to maybe talk a little bit more about native image, but as this process takes several minutes,
We can do it while it's
I'm going
building.
to first
Yeah.
just launch the process, and then we're going to talk further. Okay, so what do we do here? Oh, by the way, you can build a native image using build packs, right? So you don't have to write a Docker file, right?
Yep.
We're doing that just to show the process.
Yep.
So we are taking Liberica Native Image Kit container. It includes Liberica Native Image Kit for JDK21 and Alpaca muscle. But glibc images are also available. The next step is we are telling Maven to create a native image for us. So we are not doing anything fancy. It's just one simple command: pnative, native compile. That's it. Then, when the image is created, the native executable is created, we are transferring it into the fresh base image with only Linux. Because the native image already contains all necessary JDK classes, and it doesn't need the JRE to run. So you only use Linux. In this case, it's Alpaca Linux, muscle-based. But you can actually create static native images and try to run them in distroless containers. And in this case, the image size is going to be even smaller.
Yes. This is
Mm-hmm.
where my head is going right now. Is I want to know if I can. The build packs that I like to use are Keto build packs,
Mm-hmm.
and their base image is Ubuntu, I believe. And so
Mm-hmm.
I have struggled to get a muscle native image created with build packs, and I'm wondering if I need to create a new build pack based on the Alpaca images so that I can get this muscle smaller in image because
Oh,
that's
yeah.
I so
Mm-hmm. Mm-hmm.
for those who don't know, I like to do Raspberry Pi devices. These are small devices. They only have 512 megabytes of memory, but they're small. And the whole idea is if I want to update an image on this device, they're not really that fast. So the smaller the image, that gives me a lot, right? That delta from, hey, I've got a new image to when it gets deployed, that gets smaller when my image is smaller because it's less to send over the wire. And if I've got 1,000 of these images, those things matter, right? And it's not just for the edge Raspberry Pi devices. If you're deploying thousands of images around the globe, once you build that image, how do you get it to all of your data centers and all of your clouds? And there's this thing called ingress and egress costs when you're transferring information, especially across clouds, where you pay for every byte that you send over the wire. So these conversations, it seems like, oh, what's the difference between 200 megs and 150 megs? Depending on your workload, that might be millions of dollars, US or Canadian or Estonian, right? It's just,
Yep.
it's massive money. So these are all important things. Get your
Yeah.
stuff to work first. But then once you've got it to work and you're trying to save some money, now this is when we get into the fun stuff.
Yeah, exactly. So we have our beautiful application, right? It's ready. It's ready to to serve its purpose. but then we have to deploy it, and then there's the startup issue, the memory footprint issue, and so on and so forth. And we have to optimize something, right?
Yep.
Get the best results. Right. But actually, Ballsoft has build packs with Liberica JDK and Alpaquita.
Whoa, where's that?
Yeah.
See, this is why we're doing this show. See, where is the Bellsoft build pack?
So you can visit, so Alpaquita containers, there's this page, elsewhere.com.
All right, I'm going to go there.
It's w.com. Alpaquita containers for Spring Boot apps. And then on the bottom of the page, there is Alpaquita build pack.
Oh boy, like this is a gift. Hey, Maelstrom, like thanks for jumping in. Raymond asks, does this affect the memory footprint of the running container? Absolutely it does. Yes. What we're doing with native images and with Layden and with CDS, it does affect the memory footprint. You're going to get better usage of the memory when you're running this. So not only are we starting up faster, but on everything that we've shown so far, you're going to have a smaller memory footprint.
So, yes, yeah, exactly. Because when the JVM needs to warm up, it uses more memory than when at a stable state, because it needs somewhere to store somewhere the profiling data and bytecode cache. And when we are shifting the compilation, the optimizations to the training runs or to the build time, then the memory footprint is going to be smaller, right? And with native image, the application it's already pre-compiled. Everything's done, right? And there's going to be no warm up whatsoever. So, and again, there's not going to be any memory overhead. So yeah, and the Alpaquita build packs, they are based on Alpaquita and Liberica JDK, and there is also a build pack with native image. So you can. The only thing actually you have to do is to specify the builder if you want to try it out.
I do. I'm giddy right now. Kat,
yeah.
I spent a lot of time building the ARM64 build packs because Raspberry Pis. And then the M1 machines came along, and then my friends were like, hey, I need ARM64 native images. So for a while, I was delivering ARM64 native images. So now my next question is the Bellsoft, this builder, is it multi-architecture?
It's, currently, right now, it's x64, but in a month, in the beginning of November, there's going to be the Alpaquita Linux build for ARM64. And believe me, I'm waiting for it
this is exciting.
This is, I've been looking forward to it more than anyone in the world.
Good. I feel like I went down this path once with Pasha, saying like, hey, I'm happy to help because this is exciting, right? If I can get this a native image, right? A lot of our development teams, and this is another value of having the faster startup time. If we're working on a project together, we're on opposite ends of the world. So those smaller container sizes allow me to transfer the latest bits. Hey, I just got done doing version 1.9 and I can send it to you. When it's only 200 megabytes, like, hey, sweet, you're going to get it in a few seconds. And that wasn't always the case, right? We didn't always have that. And now with these native images, we can make our images even smaller. They're going to start up faster. So the other value for me, speaking as a developer, is I can run these native images. I can have hundreds of them installed, deployed to my Kubernetes cluster, for example. And if I'm using something like Keta or Knative, I can have them scaled to 0. So I can have the latest and greatest things deployed to my cluster. And when it's time to do an end-to-end test that A calls B, B calls C, they can start up in a second. So far, right? We haven't even done the native image, but even with Layden, like, hey, it's a second. And that's okay. But as a developer, I can have that. But not all of our development teams are using x86 anymore. Right? Some of them are using Raspberry Pis or M1s or other, right? There's more and more of these ARM64 based machines coming out. I think that there's some new maybe it's a Microsoft machine that's based on Snapdragon ARM64
There are,
that people are
I
pretty
know that
excited about.
ARM servers are on the rise
Oh yes,
in
our
the
friends over
cloud.
at Ampere are doing amazing things. I actually have an Ampere
Mm,
server back in there, so yeah,
cool.
like it's exciting.
Yeah,
Yeah,
super exciting. Yeah, and
yeah.
if you want, we can try. Well, this big build back out, or maybe even now, because
Oh, I'm
uh, yeah.
I'm I'm
So
way ahead of you on that.
yeah, right.
So,
So
but I'm on x86 or I'm on ARM64 now, so I'm gonna install that over on an x86 machine. But let's keep going with this.
all right, yeah. So let's go back to our native image. So we have created our executable, native executable, and we're transferring it into the fresh base image with the Linux only, and then we're running it. As simple as that. Okay, let's see what we can do. So let me clear the screen and move to another folder. Oops, sorry. All right. Okay.
And we're only using the Docker files so we can show our work, right? Like we
Yes.
don't
Mm-hmm.
friends
Mm-hmm.
don't let friends. And I'm saying that again because we have like 5 times as many people as we did when we said that earlier. Uh, Friends don't let friends use Docker file, use build packs. And now we just showed you a really cool build pack option. So we have things to do. So Siva, our good friend Siva, Java Spring matured ecosystem plus the innovation of GraalVM and CDS equals dev, productivity, resource usage, efficiency. Yes, like we literally can deploy enterprise architectures to I happen to have a little Raspberry Pi cluster here to like a small footprint like this, and it'll work, right? I have other friends, my friend Dustin over at SitePro that does enterprise grade. Like, hey, they're managing water municipalities, water treatments, and oil refineries with small clusters of devices that are low powered but they're highly resilient. They're HA. They have all the things they need, and everything doesn't have to be running at the same time. So you can scale these workloads up and down as you need to, as the devices and sensors that they're connected to are emitting data. So this is exciting.
Yeah.
We're in a whole new world, and never again do we have to let our friends say, "Oh, you got to use Python for that." No, no, you don't have to use Python or Go. You can get all the benefits, all the things, all the performance stuff without changing languages. You can still go to production and you can compete and a
Yeah.
lot of times exceed.
And that's really exciting. That's just amazing because yeah, well, several years ago, Java was considered slow, and then maybe you should write use another language, right? So as you mentioned, but
Not
no,
anymore.
you can use our favorite Java,
Yep.
and then it's going to start just as that.
And not only that, the Spring team makes it so I can deploy Java, I can get Java out the door fast because
Yeah,
they give us all the nice abstractions. So not only do we have improvements in the Java ecosystem, thank you Siva for that comment, but also the Spring ecosystem is making it so we can continue to take advantage of all those nice
yeah,
features from
exactly.
the Java team. Thank you, and
Yeah,
we can still get to production faster. It's a
yeah.
great time to be a Spring developer, that's for sure.
That's for sure, right? So I love Spring Boot. That's my favorite framework. It has always been, and I love Spring Boot. Well, first of all, for the community because it's so, wow, it's just so,
Yeah,
so great. But
shout
also
out to our
for,
community that shows up. Right,
yeah,
we're
yeah,
talking about startup time, and we have hundreds of people showing up from all over the globe.
that's just amazing. That's amazing. For me, the Spring ecosystem and Spring community is a whole big family, right,
Yeah, it
of
is.
people who are ready to help each other, and that's great. And another thing why I love Spring Boot is that Spring is that the speed with which Springs adopts new technologies, right?
Yes.
So there's GraalVM support, CDS support, right? Well, anything, Crack support. Actually, Spring Boot supports Crack. You don't have to do anything. Just add
Yep.
one dependency and you're ready to go.
Yeah.
Well,
Yeah.
that's
We've had that for a while. We've been talking about it for like a year now.
yeah,
But yeah, the Spring team is amazing at finding where developers are, meeting developers where they are, and giving them
mhm.
the abstractions that they need, or that a lot of times these abstractions are coming from the community. So yeah, it's a great time to be a Spring developer, and thanks to
Yeah,
the Spring engineering team.
yes. Right. Okay. So I have already built the image with the native executable. Well, don't be too excited because as I have already experimented with it earlier today, it pulled the well from the cache.
Ah, okay.
cache. Yeah, but usually it takes several seconds or minutes. Sorry, minutes,
Yep.
not seconds, and several gigabytes of memory you have to allocate to the process. But that's no limitation for me because you just wait once and then you enjoy the fast startup. Okay, so the image is ready. Let's check it. Okay, here it is, native image. It takes 206 megabytes, so the size is almost the same as with the standard jar file, and that's okay because sometimes you get smaller images if, in case of smaller or more simpler application that doesn't use a lot of JVM classes, JDK classes. But Spring Pet Clinic is a very good
Interesting.
reference application. It uses a lot of JDK classes, so the image is almost as the same size.
That's interesting because uh, the standard image, that included the JVM, right, in
Yeah,
the image.
yeah,
So
and
a lot of times,
mhm.
yeah, a lot of times it's smaller. I'm wondering why it's that big because we'll come
uh,
back to that. Just
yeah,
it's a
well,
bigger project.
that's the bigger. Well, again, if you use a really small basic application, it's going to take several kilobytes of memory, not even megabytes. But
Yep.
that depends. But again, so let's try to run it, right? So we are
Yeah.
here for the startup. Okay, so take a run, and that's going to be the image, and that's it. It started in
Dozens
0
of
for
milliseconds.
milliseconds. Yeah, that's
That's
amazing.
awesome.
That's awesome. You're right. It's
Okay,
just
so this is Spring Pet Clinic. We started at uh, 4 something seconds,
yeah,
right? When we
almost
just did
five,
the
almost
the
five. Yeah.
standard, yep. And then
Mm-hmm.
we did the CDS. We did AOT and CDS. We combined them both. You don't have to combine them both. You can use the AOT by itself and get a startup improvement. You can
Yep.
use CDS by itself and get a startup improvement. You can combine them together and get even more startup improvement. And then we went to Layden, and Layden brought us from 2 seconds with AOT and CDS down to close to 1 second, and
Mm-hmm.
now we're sub-second.
Yeah. That.
Same Spring Pet Clinic. It's still Spring 3.3.4. We get all the benefits.
Yeah.
This is hot, right?
Yeah.
So, uh,
And yeah, we didn't change anything in the application. That's the same application in all these cases. So we didn't change anything, right? So we're
yep,
just using different solutions, and that's it. That's how far we can go.
that's
That's amazing.
fantastic.
Yeah.
That's
Right.
fantastic.
Mm-hmm. But
But
there's one more thing. Yeah.
yeah, we have one more thing, right? Raymond's question at the beginning. I think it was Raymond. Yeah. Hey, he said I came in a minute late. Are we going to go over crack?
Yes,
Let's do it.
exactly. So I've left it for dessert, so to say, because Crack is that's a very interesting project. It enables you to pause a running and warmed up Java application, save it to the file, so create a snapshot, and then restore the application from the file from the exact moment it was paused. It's like a video game. You come to some point, you save the game, and then you return to it, resume playing with all the achievements that you've got, with all the vacations, I don't know, with all the challenges that you've passed, and at the same spot that you left it. And that's the same with Crack. And yeah, so let's see how we can use it. But there are several considerations with Crack. So first of all, it's based on Creo, which is a Linux technology. So it means that you can run Crack on Linux only, right? As we're doing that in a container on a server, that's okay. But yeah, another consideration is that Crack saves the whole Java heap with the whole information that's there. So
Everything in the heap is
yeah,
getting written down to disk.
yes,
And this
yes,
is only available on Linux operating system,
yeah,
right? Because it's using
exactly.
features from the Linux kernel. And this is interesting, right? This is really an interesting thing. We have some caveats, right? We have to worry about some like security things, right? My database credentials are in
Mm-hmm.
there, and that gets written down. So we got to be really careful
Yes,
about
yes.
how we handle
Mm-hmm.
that.
Mm-hmm. Yeah, so it's a stateful approach, right? So it's not stateless, it's stateful. It means that you have to keep an eye on what is there in your heap before you create a checkpoint, before you create a snapshot, or you have to introduce some security measures to guard your snapshot from somebody else. Then that's it. Okay, so let's see what we can do with that.
So what are we doing?
Yeah, what we're doing. First of all, that's the, well, you know the drill. We are creating the executable jar with a simple clean package command, right? Oh, yeah, by the way, we are using Liberica runtime container again. Because Balsoft provides ready container images with crack support. So you don't have to configure anything, right? So you just take this container image and you're ready to go. Yeah, so that's very convenient. And if you use Linux on your local machine, you can download Liberica JDK builds directly from the site with the crack support, and just skipping the containers, you can try using that on your local machine, right? So maybe that's going to be easier. So the first time running crack, it is might seem scary, and I'll show you that right now.
The Liberica version.
Yeah, so it's
in SDK man, does that support crack?
I have to specify that with my team, because I know that there are for sure builds with crack support on the site. That's on the site.
I'm looking. Yeah, because I know that I have the NIC, and I feel like I've done this with Liberica for crack as well. I'm peeking. Sorry to distract.
Yeah, it's okay. Right. So yeah, but I have to just consult with my team whether there are builds.
Yeah, I don't think it is. All right. There's not a different version from what I see now. There's not a different version that says crack support.
Yeah, so there should be a tag or something.
I feel like I've done this, so yeah, we'll come back to that.
Okay, yeah. All right. So okay, back to our Docker file. Unfortunately, you can't use crack with build packs right now, but yeah.
Right, and the problem is with the build pack. If I'm creating that OCI image, it's kind of like a two-phase thing, right? We have to like start it up and connect, and the build pack, that's not the build pack's job. So figuring out a way, and I know there's a lot of amazing people that are thinking about this. If we could have it so that we have an image that gets deployed to your platform, and have your platform be like, oh, I see you've got crack support in this application. So we're going to start it up. We're going to build a snapshot that you can start up from later. So on this first run, we'll take a snapshot, we'll write in disk, so that when we scale instances 2, 3, 4, and 5, they start up like this. Or when we scale to 0 and we start back up, we start up from that snapshot, which is exciting. And I know that there's people that are working on that and they want to make it secure. So this is great. Like, we're in a really great place. The idea is amazing, and the results are amazing as well.
Yeah, that's it. So okay, let's see. We have our executable jar, and then on the next stage we are creating a layer jar, just like we did with the CDS, right? So everything's familiar. Then we are transferring our layer jar into the fresh base image.
You just blew my mind, because when I didn't even think to do the AOT CDS stuff. I can still do the AOT CDS things with Project Crack. I didn't even think to do that because Project Crack is so fast. I was like, oh, that's not going to, but it will make a difference. Not only is it going to make a difference on the startup time of the initial one, but it's also going to make a difference in the footprint of the running Kraken. So if startup is just your thing, yeah, don't worry about doing the AOT and CDS stuff. But if you want a fast startup and you want to have a better memory footprint and you don't want to trade off any of the JVM features, this is kind of exciting.
Yeah, so crack actually, that's super cool, and that's the difference from the native image. Yeah, so native image is a different story, right? So it's it's not Java that we're used to, and there's a limited choice of garbage collectors, and the performance is quite okay. but there's no dynamic performance optimization, right?
Right.
And with Crack, you can have that. You can have this instant startup and still have your JIT compiler that performs some optimizations on the fly. And that's amazing. Right.
This is very, very cool. But yeah, you dropped another egg of knowledge on me. And let me just say thank you again for hanging out with me, because I've learned a bunch, and you have taught, like, this is just great.
Yeah,
So
well,
I got some notes.
well, I'm actually really excited to be here, and I'm excited to talk on this topic because I like it so much.
Yes.
Right. Okay, so the most interesting part in this whole Docker file is here in the entry point. We're not doing anything while we are building the image, well, nothing fancy, right? The whole stuff, the whole magic happens when we run our container image for the first time.
Okay.
Because in this case, we are telling our JVM that first of all, we are going to, again, exit the application automatically when it starts fully, right? But here it is. The most important part is crack checkpoint 2 flag. So we are telling the JVM, please create a snapshot of the application and store it here in this place. So checkpoint.
Okay. That's where it's going to go on disk.
Yeah,
Okay.
exactly. And then we are going to transfer this checkpointed application to the fresh container image and then run it. So yeah, this is our first stage, so to say, right? So we are just preparing the grounds.
Yep.
And then again, we are using the jar launcher to work with the layer jars.
Our friend Simon says, "Thank you for the interesting talk." Like it's good. We're the audience is
thank you, Simon.
Hundreds of people from all over the globe, so we're doing good things.
I'm so excited. Right. Okay. Let's see. Let's go back to the console. Clear the stage.
While you're doing that, I'm going to remind everybody that my mom and dad like to watch my show, and they're always interested to hear where people are joining from. So if you're in the chat, or if you can, say hi and let us know where you're from. And hi, mom and dad.
All right. Okay, so I am in the directory of my project, and we are going to build our first image, which we're going to call pet clinic. What are we going to crack checkpoint? Crack checkpoint. And we're using the Docker file crack for that. Okay, let's see. Right, so the easiest part is ready. The container image is ready.
Okay, so
that's just the beginning.
Okay, got it. So it's kind of like our training run. It's we started up, we're good, and then we wrote a snapshot down to the disk.
Yeah, and that's not so here it is, our container image, crack checkpoint, and now we are going to run it. And as soon as we run it, we are going to enable this entry point line that I talked about, right? So, and then when the application exits and we stop our container, the snapshot is going to be created. So the command may look pretty complicated, but don't worry. I'm just going to explain you everything. So for that purpose, to run the application and checkpoint it, you need two capabilities. First of them is the checkpoint restore. It enables you to checkpoint your application without running the container with the elevated permissions. Right. But this capability is available with the latest kernel versions, 5.9 as far as I remember. So if you're running a Linux distro with the older kernel version, then you can use the privileged flag, but it's not recommended actually to run containers with elevated permissions, but you can still do that. All right, and the next capability that we need is system ptrace. All right, Let me check it. Yeah, okay, that's fine.
Okay.
That's fine. And then we are creating the intermediate container. Let's call it pet clinic crack. And we are specifying the our image that we're going to run pet clinic crack checkpoint.
Oh,
Yeah.
you're
Right. So again, let me repeat what's going on
yeah.
here. We're
I'm
running our.
noticing that you're using the capability add sys ptrace,
Mm-hmm.
and in my demo, I'm using the capability add sys admin.
Mm.
And I'm
Yeah, but
wondering if it's because I'm using a different distro. Uh,
checkpoint restore capability is used instead of admin,
all right.
sysadmin.
So I have checkpoint restore and I have system. So I need to make some changes. See,
Yeah.
you continue to teach me stuff. I've been doing these demos for a long time, and now again, I have even more. Thank you so much.
Well, crack for me is the most complicated thing actually because it's well. Okay, so as you can see, we started our application. It exited, and here is the stack trace. So we actually, it means that we created a snapshot.
Okay.
We checkpointed our application. Right, great. We are almost done.
We have our checkpoint.
Yeah. So the next step is to what am I doing? Something's wrong. I just wanted to find this command in the terminal history. Tree. No. Just a sec. Crackers. Okay. Yeah. So, what do we have here? We need to transfer this checkpointed application into the fresh image, right?
Oh,
So we are using Docker commit for that. And we have to change the entry point. So now we are not creating the snapshot. We're not doing the checkpoint. We are restoring
this is
from.
so cool.
Yeah.
Uh,
I know.
you are blowing my mind right now.
Yeah. Well, I'm blowing my mind.
This is cool.
Awesome. That's awesome, right? So we are changing the entry point, and we're telling crack restore from, and we are pointing to the file, right, that we created, and we're specifying the image.
So when you run this, it's updating the image.
Yes, it's updating image, so we are copying the image with the snapshot, and plus we are updating the entry point,
Oh
right?
man, goodness, you're improving my demos. Like, and then the other thing is when I was talking about like, how do you do this in a build pack? How do you execute this and make this happen? Because when you deliver it, each platform, every time you're connecting to a new database or whatever, you have to have a new image, right? You can't store this in your registry and then expect that everything's going to connect the same. You can't take this image from dev to prod, the checkpoint, right? You can't take it because it's going to have the wrong credentials in the heap,
Yeah,
etc. So what you just gave me another shortcut for how could I do this? Like once I've deployed it, how do I do
yeah,
this? And I can deploy it and then I can update it on platform.
yeah, exactly, right. So
And
okay,
this
let's see.
this is
Yeah,
good.
yeah,
So
this is
now
cool.
my
It's really
if
cool.
it stays on platform, if it stays in that local registry, same cluster, for example, then I'm reducing the risk, right, of those credentials
Yeah,
getting exposed.
yeah,
This is cool. This is still very, very cool. Like this is a cheat code.
yeah.
Plenty good for development, and probably plenty good for use cases where I'm deploying it to a cluster on the edge too. All right, let's keep going. This is so cool.
Okay, yeah, that's really cool. Yeah. Okay, so we are now removing the intermediate container that we created to run the application. We don't need it anymore. And now the most exciting part to actually run the application
Yep.
from the checkpoint. Okay, so Docker run. IT because it's going to be interactive.
Our friend
Around
Icon is in the audience. Thank you, Icon, for joining. Good morning to you. This is
all right.
exciting.
Again, we are adding the same capabilities. Cap add
Okay.
checkpoint restore and system pit trace.
Got it.
Cap add system pit trace. Okay. Right. So I'm consulting my notes here so that to make sure that I didn't forget anything.
Oh, I totally get it.
Yeah.
This is a safe place.
Yeah. Okay, let's name our container clinic crack. And finally, we are specifying the name of the image with the checkpointed application, pet clinic crack restore. All right.
Yes.
Are you ready?
I think I'm ready. I
Okay.
mean, we started off at almost 5 seconds, so I expected this is going to go a little faster.
Okay. Let's see. Yay! That's it.
Now,
0.2.
so here's the cool thing. You know what we didn't see? We didn't see the Spring Boot startup message. You know why? Because we started it up already.
Yes.
Right, we're picking up from where we left off. 0.224 seconds.
Yeah. Amazing, isn't that?
And this is Spring Pet Clinic.
Yeah.
It started up almost 5 seconds. An hour ago when we started this, it started up at almost 5 seconds. And we stepped it down, and now we're starting up in dozens of milliseconds.
Yes.
This is exciting.
Amazing.
This is
love
very,
it.
very cool. Here's the big thing that I'm taking away. First of all, you shared that we have some other build pack options, right? I said, hey, I like Paketo. My friends are doing a great job over there, and they have the multi-architecture. But you also said that Bellsoft is coming with some multi-architecture build packs soon, which is exciting. And the muscle capabilities, it doesn't have to be GLC. The muscle capability, which I know from personal my build packs that it's in demand. People want that, and for myself, right? When I'm deploying to small devices, that matters. Smaller image size. Can we now look at the images? Because our checkpoint not only has the JVM and the classes, but it also has a heap dump of the heap of the JVM.
Yes.
And it's still only 607 megabytes.
Yeah.
Man.
Right. That's it. Yeah. So
Look, we're getting some comments. Raymond's like about 200 milliseconds, almost a P90 target, perfect for cold starts. Maelstrom is also saying, 0.2 seconds. This is really amazing. It is, and not only that, but Project Crack by itself is absolutely amazing. But you also, can we do this? I know it's totally off script, but can we start up each of these images don't do the port forward on them, and just start them up in the background, and then let's take a look at the memory footprint of each by doing just a Docker PS. So let's run this checkpoint restore, and we're just going to run it and let it run in the background. But take off the dash P8080 8080 part, so that we're not going to do a port forward. Oh wait, and actually take off the interactive part.
Yeah.
Right. So it's just going to run in the background, and we'll stop it later. Right.
Okay.
And this should start it in the background.
Okay. Yes.
If you hit enter, do we get back to our command line?
So I guess I need to open another window, right?
Wait, no. Control C.
Okay.
Is it the RM? Take off. What does the RM do? Docker RM.
RM removes the container. Removes the container after we stop the application.
All right. So what I want to do is just take off the dash RM.
Okay.
And I think that it'll run it in the background.
Okay. Let's see. No.
Why? What do I need to do to run it in the background?
Maybe there's some option that we need to specify.
I'll find it. I don't know these things off the top of my head.
Yeah, me neither.
But we're gonna do that, and that's okay. If you don't mind, we're gonna play with this.
Yeah, absolutely.
We want to run it in detached mode, but I don't know what. I don't know which one that is. Foreground, background, dash D. Set. Yeah, try it with dash D.
Okay, so that's the same, but dash D, right?
Yeah, dash D. There we go. We have friends.
Response for
It
demo
says-
conflict. The container map is already in use by container. Okay.
All right, so yeah.
Yeah.
So we can stop that container. Like you can copy that ID and just say Docker stop.
Right. Okay, copied it. Come on, let's do it again.
Simon says, hey, there's seemingly no application restored event yet, correct? I was looking at the Spring application event subclasses. I know what you're saying. You're saying you want an event triggered when I've done the checkpoint restore when I boot up, but there is also the it's not the same. There's not a specific event for that I know of. But that is a really good question, Simon. So I'm gonna take that note, and I know exactly who to go to. I'm gonna go to Sebastian. I'm sure he'll know. But I'm gonna take that note. I want to find that out because that would also be so. Simon, application restored event. And Simon, I'm going to ask you a follow-up question. What would you want to do with that? What's the use case that you'd want to do with that?
With crack?
Yeah. He's talking about when we do a restore with a crack image, does Spring give me an event to say, hey, I just restored from an image. So I've started up. I have a startup event, but do I have a restored event? And I'm just asking him a follow-up question. All right. So did we stop it?
Yeah, we stopped it. As far as I remember, I think I saw a message from Spring that it was restored. Starting using Java.
It'll be
profile. Well, the application it knows actually that it's being restored, so that's why it's called coordinated. The application knows when it is being checkpointed, and when it's being restored.
Scroll down to the next run.
Yeah. All right. So we stopped the container, and now we are running another container.
Docker RM wait, what?
Docker RM R
slash pet clinic dash crack, right?
Pet clinic.
I think you have to put the.
Yeah, but
I see what you're saying. So he wants it for open telemetry, right? Okay. All right. Try that.
Yeah. Okay.
Remove the dash R flag.
Oh, sorry. Okay.
All right, now we're doing it. We're just gonna do this to see. All right, so now that's running in the background.
Yeah. Oh, cool.
So now let's do that same. Let's run the other images the same way. So we'll do Docker run dash D. We don't need our capabilities, so all we can do is
pet clinic. Yeah, we have.
Yeah, but let's give it a name. So that was the restore one. Let's call this one. Let's do the standard one.
Yeah, so there's the image called standard, right?
Yep.
This one that we created. So we are doing.
So do dash name. Or no, that's fine. Just do that. Just do that.
Yeah.
That'll run, and that'll run in the background.
All right.
And let's do the same thing for the CDS one.
Okay.
And
native image.
And the native image, yeah.
Okay.
Now we can do Docker stats, I think.
Stats. Okay.
And now we can take a look and we can see our memory footprint. So we don't know which one is which.
Oh yeah, so that's something weird, right?
We can take a guess.
Them, right?
We can take a guess. Now what's interesting here is the one that we named was actually here. Let's Control C.
Control C, right?
And let's copy that container ID. The
Which
CF. Yeah,
one?
we're gonna stop those ones.
Oh, we're going to stop them. All
Yep.
right.
So let's do Docker
Stop.
stop
Mm-hmm.
with that container ID,
Okay.
and then do Docker RM with the name.
Mm-hmm. Okay.
Yep. And let's see if we
Alright.
can. We're gonna start them up again, and we're gonna give them names so we can see which one is which and how they're doing footprint wise.
Mm-hmm.
Which
That's
is
right.
this is pretty cool.
Yeah. Yeah. Okay. Do we need to remove the pet cleaning crack?
Let's do this. Let's remove the pet clinic crack so it doesn't
Okay.
have time to optimize,
Okay. All right.
even though it's not doing anything, right?
Okay.
And
And then we are removing by
wait,
name,
we got one
right?
more. We have one more. We have to get the F.
2, 3, 4. No, we have. Oh, I removed one. Okay. Okay. I see that. Mm-hmm. Yeah. Stop. Okay. Yep.
All
All
right. So
right.
now we don't have anything running, right?
Uh-huh.
And
So
now we're gonna try to yeah. Let's room.
remove, right?
Do we need to?
I'm not sure.
Let's do this. Yeah, let's remove. Let's do the RM
Remove. All
on
right.
those.
Mm-hmm.
Yeah, just to be.
Yeah. Mm-hmm. Weird names though. Right.
I think we can do this.
Karen.
There we
Okay.
go.
Okay. And this one.
So we still have the images. We can still
Yep.
start them up, but this time when we start them up, we're going to give them a name so that we know
Mm-hmm.
which one is which.
Yep. So let's. Okay. So let's start with crack, right?
Wait.
So
Yep. There you go.
yeah.
Remove that
Mm-hmm.
one. Wait. Remove. You didn't remove the crack one.
I didn't remove that, right? Oh, sorry. Yeah, because yeah. Mm-hmm. Yeah.
There we go.
Pet cleaning crack.
All right. So
All
now
right.
we
Great.
do
Yeah.
Docker stats. There's nothing running.
Docker stats. Oops. Okay. Yep.
Perfect.
Mhm.
Control C.
Right.
History. Pipe grep. Run.
I think it's going to be easier
Yep.
to just
That
find the
works.
command.
And do. Yep.
Yeah, this one is, yeah, we already named it, pet cleaning crack, right? So we're running it.
Perfect.
Okay. The next one is, okay, it's just pet clinic standard, and we are going to name it too, right?
Yep.
Okay.
-- name. Pet clinic standard.
Mm-hmm. STD. Okay. That's
Sorry
it.
to put you on the spot here. This is something that wasn't on the
That's
script,
great. No,
but this is my wheels are turning. We had the question, so we're just going to name it. We're going to take a look because the thing is, our Java workloads can start up faster, but there's tons of other capabilities and features that have been added to the JVM, since your mom and dad used it, right?
Yeah. Okay, so we have our 4 containers running.
And now we can do Docker stats.
So, okay, let's see.
And now when we look at that memory usage, now
Oh.
we can see which one's which. The CDS is running at 343.
Mm-hmm.
The native image is running at 106 megabytes. The standard image is running at 324 megabytes. And the crack image is running at 61 megabytes.
Mm-hmm.
Right? So they've had time to optimize, so things aren't, same for same. But this is pretty exciting.
Yeah.
This is very exciting.
Yeah. By the way, with Packlink CDS, there can be multiple JVM processes using one archive.
Yes.
So the memory footprint is going to be smaller. Well, the more JVM processes, the smaller the footprint on the whole. Yeah, amazing. God,
This is cool.
That's great. That's so cool. Wow.
I am surprised. Now that we're watching it, I'm surprised to see the CDS footprint a little bit higher than the standard image footprint. And that I'm just curious about that because I have a similar demo where I kind of go through these things and I take snapshots along the way. So I'm gonna look at that. But the startup time for the CDS image was much faster. Oh,
Hmm.
we we didn't make an image for the Leiden, and that's
Because
okay. Yeah.
well, there are no
Yep.
containers.
Yep. We don't have a container.
Yeah,
So yeah, this is cool. Very, very cool.
that's
Very
amazing.
cool. Thank you so much for that.
Right.
That was
Well,
slick.
thank you. That was amazing.
Well, Kat, this is great. You got me excited. You have me, wanting to go and try out some new things. Uh, Thank you so much for hanging out. And I'll open up one last time, to the audience. Any questions that you have, get them in because this was fun. I know what I'm going to go do. I'm going to go and try out the Bellsoft build packs. I'm going to go modify my Project Crack builders
Yeah.
so that they actually use the AOT and CDS, and I want to see a difference. I'm gonna go try out Leiden. I'm gonna go download a Leiden build, and I'm gonna watch this. Did you have a GitHub repository with this code in it by any
With the
chance?
well, I can create a repository with all these Docker files,
I think that would
and
be
I
valuable.
have and I have 4 tutorials actually.
Oh, how about that?
Yeah.
Do you want to share those links?
Yes, of course. So I can send it to you. Them, just a sec.
Yeah,
How
we
can
can
I
do that.
to the
There's a
chat?
private chat for us.
Okay. So this is Leiden.
Oh, this is great. All right,
This is
we'll put those out
CDS.
there. Sometimes, depending on where people are in the world, the
And this is crack. Mm-hmm. All right.
here we go.
Yeah, so take a look at these tutorials because I know that right now we gave a crash test to all these approaches, and you might want to repeat them on your machine, right? And these articles contain step-by-step tutorials with the same code that I've been using. So copy and paste.
Fantastic. So I'm going to just throw those up for people that are watching. We did, there's how to use Project Leiden. And then here's the how to use CDS.
Mm-hmm.
Fantastic. And then the last one was using
Correct.
Crack
Yeah.
with a Docker
Mm-hmm.
container.
Yeah.
And I'm going to go steal some code from there. So this was
Well, please do. Please do.
fantastic. If people want to find you on the internets, where should they go?
Well, they can connect with me on Twitter.
I think I
So
have your Twitter right here. I'll throw that
yeah.
up.
Mm-hmm.
That works. Do you have a blog or anything?
Well,
Oh,
I blog
I see your
for
Medium.
Microsoft, and there is
Yeah,
the blog on Medium that I
awesome.
have. Yeah, and sometimes I post articles there, mainly digests or some Spring Boot tutorials, which are also quite useful. So just I don't remember it. Otherwise, maybe somehow. Well, I guess you can find me there,
Yeah.
Medium too.
Now, if are we going to see you in public anywhere? If somebody wants to buy you a coffee, are you doing any conferences?
Yes, yes. So this year, so by the end of this year, I'm saying put. But next year, I'm going to come to KubeCon in London,
Okay.
and I'm definitely doing Spring I/O with the presentation. Hopefully,
Yes.
right? Yeah,
Fantastic.
going to be there. Definitely. I really want to meet everyone.
Spring IO is an amazing conference. I highly recommend it. Yes.
Thank you. Thank you so much. Yeah. So
All
hope to
right.
see everybody in person. That was great being here today. That's fantastic. Right.
Thank you so much. Well, everybody, thanks for joining. And Kat, if you wouldn't mind sticking around, I'm gonna close off the stream, but I want to chat with you a little bit
Yeah.
more.
Sure.
So thanks everybody. We'll see you next time.